AI or maybe GAI, you really do need to think about what intelligence is or what human intelligence is. I think, gone are the days where you can like build a neural inspired architecture and turn it on and hope that, it's going to be a cat. It's not going to be a cat until you figure out, what cats do and how cats think, or what humans do in this case and how humans think. So yeah, I'm really excited to see where the field goes. I'm kind of now in a different field using some of the same algorithms, things like meta learning and transfer learning. But yeah, it's I think if we're really gonna get to some true AI in our lifetimes, we'll need to really understand more about human intelligence.
Yeah, beautiful. And next, can you tell us more about your work as a scientific research, working on a multitude of fascinating projects at the intersection of clinical science and machine learning? Can you describe what your team works on and why?
Sure, happy to. So I think the elevator pitch for the work that we do is that I think there's really fascinating biological research to be done, leveraging the huge amounts of data that are available to us, sort of in a healthcare setting, and while simultaneously like figuring out what machine learning methods actually work for this like real world messy data. Um, and I think we're able to ask pretty impactful questions. So we're able to ask questions like, what put someone at greater risk for like a cardiac event, or what are the genetic associations of a disease like excess liver fat accumulation? And I think we're able to ask these questions more precisely than we have in the past. Um, and like a tangible example of asking more precise questions comes from some of my colleagues, Saket Agrawal, Marcus Clarquist, and others, where they were actually able to show that type 2 diabetes, you can have different disease risk even at the same body mass index. So body mass index is weight by height squared. It's a ratio that's meant to sort of be this all it fits all kind of metric, but that has never really been the case in the way that it was designed. And they were able to show that type of body fat actually matters a lot more than what that number is. And not only that, there's some types of body fat that are like protective against type 2 diabetes. So that's sort of unintuitive, right? That you can have a higher BMI, but be at lower risk than someone with a lower BMI, depending on what type of body fat distribution you have. And so I think that sort of precision and granularity is really important, because then we can better identify which people are at risk, and how to deal with that, like from a public health perspective. So you can imagine going into a doctor's office in the future, and then being able to quantify your body fat distribution with like a phone camera instead of having to like compute a number. And I think that has like real implications on human health. So that's really exciting to me. Our sort of flagship project recently is called the Community Care Cohort Project. We affectionately call it C3PO because we're suckers for Star Wars puns. And that also sort of speaks to the scale of what is possible. So we have this huge longitudinal primary care cohort, over 20 years of information from the NGB healthcare system, which is like one of the biggest healthcare systems in the country. And so we have echoes, ECGs, MRIs, EHR data, just in the millions of data points, right? And millions of images. And this is the scale that sort of tech giants use for like photo recognition or machine translation. And we think it's really important to do this scale of development in the context of like curing human disease in mind. So I think that's a really like vision-driven, mission-driven focus of our research. And maybe to give you like a specific example of a project that I've been working on, I've been doing natural language processing on clinical text with my colleague, Chris Reeder. So if you've been to a doctor's office recently, they usually take like height, weight, blood pressure. And that's usually something that happens like every time you go into the doctor's office. And it's like, that's important stuff, right? Like vitals are essential inputs to many of the models that we build. So it would be nice if we always had that information for everyone. But unfortunately, like the real world is messy, that's not always available. So we're actually able to use like transformer type models on like pre-trained on clinical text and actually extract height, weight, and blood pressure with like perfect precision from this like unstructured text written by humans. So I think that's an example of a way that machine learning, other machine learning method can be used to improve the quality and the quantity of data available to us, even in like traditional clinical research. So like even if you're using like ML for to get these like vital signs, they can go into like risk scores that doctors use and sort of need on a day-to-day basis. Um, that's my little spiel. I hope that's like a good vignette of like the things that our team has been working on and thinking about. And I'm happy to like answer questions later on or connect offline.
Wow, that's a lot of really cool things. Thank you so much, Pulkit, for sharing. And then finally,
I'm sorry I disappeared. I live near O'Hare Airport, and periodically I get knocked off the internet, and it took a while to get back in. So.
oh, no worries. Pulkit just told us a lot about her project, her team, and we'll probably hear more about it as we talk more. So you won't be missing out too much. So finally, Mariani, we've heard about the amazing work that you do with your nonprofit. So could you talk us through your motivation behind founding the nonprofit, any challenges you faced, and any advice you may have for our younger audience and interested in a similar project? And just one more question, I'm going to slide in there. And how do you ensure that you get recognized at the broad for the community work that you do, both inside and out of the institution?
Yeah, the nonprofit that I work at, that I founded, was STEM for All Brockton. So during college, I took computer science. I was one of the few women in the whole major, and also one of the few person of color through the whole major. So during that time, feeling like an outlier, I looked around and saw there was no one like me. And I felt every time I raised my hand, because I was like one of the, or in some of my classes, the only woman in the class. Raising my hand, I felt like I had to represent all womankind and all like my race and everything. And it was very stressful. And I remember just feeling like I do not belong there. Later on, as I continued the course in the class, I realized I do belong here, but why is it that there is not more women, not more people of color in these classrooms? And I decided, after doing like my own little research, that it's because I come from a low income family, and in certain areas there's no access to STEM education. So I became very adamant in the drive to promote STEM education in low income families around my area, and hopefully it gets more recognized around the world so everyone can have access to choose what they want to do with their life. And with healthcare, tying it back in, there's so many disparities in healthcare right now for people of color, for women. And I feel if people can gain the knowledge at a young age, they can choose which path they can go to. That's why I'm so grateful for things like this. And going to the STEM for All, we do sessions teaching kids from ages 6 to 25, STEM courses, whether it is science, research, computer science, computer engineering. And for anyone who wants to do projects like this, I say if you're passionate about anything, go for it. It started as a little program and then grew into this nonprofit. So follow your dreams. You can do anything. And outside of that, how to get recognized for your work at my job. So in my job, I also work to create safe spaces for people of color in my job. And that work gains skills. We're talking to clients where I have to do as a field engineer anyway, talking to scientists and understanding what they need is the same skills I gain doing community work. And I talk to my boss and explain, since I'm getting the same skills, I should get counted for my D&I work as long with my scientific work. And after many conversations, they added to my job ladder. So even though I'm doing two kind of jobs at the same time, I still am up for promotions and up for career growth.
Thank you so much, Whitney. You gave us a lot of really good advice about community building and making sure that our the people that we come from also have the same opportunities that we're gaining right now. And you also said something that I think is very important about like following your dreams. So in that sense, what for anyone in here, what made you choose this specific field in healthcare to explore further? And maybe like what was your first project that you worked on that showed you that this is the path for you? Maybe Sai, you can tell us a little bit.
Yeah, thank you. So I actually started, so my PhD was like my focus was computational cognitive science, but we were an interdisciplinary lab. So it was the general field was computational psychiatry. So it was using AI to see if we can understand, the algorithms humans run when they think, and then see if we can actually figure out, maybe what's going wrong, or maybe what's slightly different when someone is making a decision or doing something that might be detrimental to their mental health, or if someone makes like has OCD and makes continuous action over and over again, what's actually going on in the brain that's causing them to make that action. And I went into the field because I thought it was really interesting. But the more you look at certain fields like women's health, mental health, they're just so underserved in so many ways. There's so much, mental health that particularly is really like diagnosis is extremely difficult. So what we were trying to do is kind of come up with a computational assay to see if we can say, okay, here are the different biological features of this person, and here are the computational features of this person. They have, not just OCD, but OCD type 1, and here's a good treatment path for them. And, right now it really is, there's no disease subtyping. There's just these broad swaths of diseases that clearly do have subtypes. Things like schizophrenia, or I focused on behavioral addiction. So the patient group that I was really interested in was pathological gamblers. So why do people take decisions under high risk? Or I think there's a lot of behavioral addiction and potentially gambling behavior we're seeing right now, as people are using social media more and more, and some of the stimuli and rewards signals they're getting mimic those that you would get in a slot machine. And so I think it's a really interesting issue for us now. But again, we don't really have a strong diagnostic for, okay, this person actually has this behavioral addiction, that's why they're doing this thing. So like many of the other panelists have said, just diving into the field, you really see where all the cracks are and how much you can add value by bringing a set of computational skills, for instance. And I think, kind of growing up, also, being one of the few women in physics, I think, it was really hard for me to kind of stand up and believe in myself that I actually had value to contribute. I remember, when I started my job that I have now, I kind of pulled my manager aside and I was like, oh, I don't know if I can actually add value here. I've had so much imposter syndrome. And so, whatever we can do kind of to support each other and help disabuse ourselves of imposter syndrome. There's so many interesting problems, especially in ML for healthcare and health tech, and we all add so much value. And I get also just emphasizing like the contributions we all make coming from the different perspectives we have. Being a woman, you bring so much knowledge, just having that personal experience to these problems. And so I really, encourage you all to, again, echo the other panelists, just do the things you love. You are definitely going to add value. And seek out mentors, and talk to people if you're feeling insecure. They will help support you and uplift you.
Yeah, thank you so much.
So,
Oh yeah,
oh,
go ahead,
you want,
please.
okay. Oh, are we all supposed to answer the same question?
Yeah, go ahead. Yeah.
Oh, okay. I was a math and physics major in undergrad back in the day, and I've always liked the problem solving aspect of that. I never quite got into like going to medical school or anything, but I really enjoyed the physics applied to the medical field, and that's why I went into medical physics. And it's great because it has math and physics and computers, and you learn some biology, some medicine, and it's very interdisciplinary. And I've been doing it for decades, and I really enjoy teaching other students about it. And they now have gone on, and it's great because my students have become colleagues, and so it just worked out. My master's was in physics from University Exeter in England, where I worked in the assembler language on a Motorola 68000 chip, and did my master's thesis there on electrocardiograms of babies, well, of adults, but with the goal for SIDS. And then I came back and worked on the emerging field of digital radiography and looking at the signal and noise ratio, resolution, spatial resolution and noise, and then I went into AI.
A broad range of expertise we can see. Thank you so much, Miriam. Um, Mariani, would you like to tell us a little bit about how you came into the intersection of healthcare and technology?
Yeah. When I first learned about coding, I fell in love with Python and Java, and I saw one of the questions asking what useful language for the healthcare. I know for like my field, data science, R and Python are really, really big. And I fell in love just with coding in general. And I knew if I wanted to code, I wanted to make a difference in the world. And I applied to the Broad, and now I can do that. I can help scientists. Like, for example, there was when COVID hit, our company was taking COVID tests taking COVID vaccines. Sorry, not vaccines. The tests. 10,000 a day. So we'll receive 10,000 tests and send the 10,000 out. We are now at 3 million a day. And to do that jump, I was a part of that team to help code a pipeline. So when the scientists finish like analyzing it and has like positive or negative, they go through our pipeline and they can send it out faster. And even though I worked on it for about a month, that month was really, really stressful, but I love that I can make an impact and do what I love, coding and helping out. And I think that's what brought me here. But I love this panelist because I'm thinking of going to AI in the future. So I'm just learning so much about what everyone else does. It's great.
Thank you so much. And it's so impressive how you were able to like work on a team, scaling such like large numbers of COVID tests a day. That was crazy. I thought 10,000 was a lot, and then you said 3 million. Yeah, very impressive. Paul, can you, Riley, tell us about how you came into healthcare and tech?
Sure, yeah. I was a computer science major at Princeton. That's where I did my bachelor's degree. Actually, weirdly enough, similar to Sai, my undergraduate research was in computational cognitive science, and I thought that was really cool. I was almost a philosophy major, but I thought instead of armchairs, maybe we should sit at coding terminals and sort of ask similar questions. So my undergrad thesis was in like image categorization. So can we put like constraints on vision models that sort of correspond to classic like psychological theories of like object recognition? And I just really, really love like the application of the application of like principles from cognitive science to machine learning. And I think transitioning to machine learning for health was sort of came from that similar place of realizing that like biological mechanisms and systems are like infinitely complex and we understand so little about them, but they're also just like, they work, right? Like we're here talking, breathing, building community. Um, and being able to sort of think about things from like a systems perspective is really interesting because there's sort of the people that I work with are just like incredible clinical researchers and doctors. And I think being able to ask them very dumb questions as we build our machine learning models is like a really, really great setup. And I sort of saw in the chat about like how do you integrate medical expertise, and I think that's a really like crucial question because these are like this is a high impact situation, right? Like we don't want to mess this up, and I think the only way to move forward is to make sure like the experts are involved because they train for years for this, right? And me building a model in 3 months is not the same level of expertise. So it's really important to make sure that we're grounded in the biology and we're sort of thoughtful about how these kinds of systems like interact with the world, because we definitely want to make sure that we're making a positive impact. And I think there's lots of positive impact to make, but we need to make sure that it's positive and not negative. But yeah, it's so good to hear from the panel. Like I'm thinking about graduate school too, so it's really nice to sort of like all talk together about what we're interested in and like how to pursue it. So
Yeah, thank you. And I think you raised a really important point that most of our viewers are raising about how to integrate your team from being like, very technically aware to not so professional in like the more healthcare sense. It would be wonderful to hear from you, from all of you, how has it been in organizing your teams with both the medical professionals and the computer scientists or the data scientists, and how has like the communication among those two sides been able to be like, facilitated?
Yeah, maybe I can take a stab at it. Like Pulkit said, like this is the question. Building interdisciplinary teams is a really, really hard problem because everybody comes from their different perspectives, and if you're doing AI for a biological application, biology is infinitely complex, and no AI algorithm is gonna solve biology, right? I think the key kind of element is everyone needs to come to the table with a huge amount of humility. Like you need to understand that you bring a set of skills, but you're contributing to this problem just as much as this person who has a background that you know nothing about is also contributing to the problem. And that you really need all hands on deck and like a very strong sense of mutual respect across the disciplines. And that can be hard. I think a lot of times people will sometimes feel like, oh, well, this AI is showing me all this amazing stuff. And then a biologist will look at it and say like, okay, but that's super obvious, like, and so it is this back and forth and this constant, sense of grounding yourself and thinking, okay, well, I need to, I'm just contributing. And I think, we use the term AI, artificial intelligence for healthcare applications, but I think when it really comes down to it, a lot of it is really augmented AI. Augmented intelligence. So you're building a system that's maybe making recommendations about, I don't know, interesting drug targets. And you need an expert to then look at those predictions and tell you, okay, this makes sense or this doesn't make sense and why. And then you can maybe use those annotations to improve your predictions during the next round. But it needs to be this interaction of tech and expert. We're so far away from being able to be fully tech and just have an AI tell us everything.
Yeah, really great points about making sure like your results as a computer scientist is interpretable to the medical professionals. And can anyone like here say anything about how it's been trying to to acquire information from the medical experts as maybe like it might have been quite a while since you've taken a biology class or something related to that. How's the accusation process? Yeah, Marilyn.
Yes. Well, we're very lucky. Our AI, our medical physics, that's been around since the mid 1950 around, is embedded within a medical center. So we're a physicist working with the medical field, and so we have great access. We have the breadth and depth that we need there. Our teams are so within my lab. I have about 12 people. Beside, we have graduate students, but we also have computer scientists. That one is the interface. Another one is for security and connect interoperability. The other one is for more database. And then we also have senior researchers in the lab who help lead the various projects, and all the projects are, in a sense, AI aided. We're not going to replace radiologists, don't worry. And we have most of them are in the medical field, so we work with a lot of radiologists, but I also work with surgeons, oncologists. But we also have some of the AI at the microscopy level, confocal microscopy. So we work with the biologists there, but interdisciplinary, and also around the table, everyone in a sense is equal on the science. You know, we all bring something different to the table, and I always stress everyone play nice in the sandbox, and we all work together. Whether you're the high school kid rotating during the summer in my lab, or the big professor, doctor, or someone, but we all communicate. It's a very nice.
Yeah, I think also at the Broad, it's very collaborative, and that there are scientists on deck in labs. So sometimes we just go over there. Well, when it was pre-COVID, we go over there and then meet with them and talk with them. Now everything's on Zoom, and I think they're very happy to explain things. There are times I didn't know where, like when I first came, I didn't know what comes out of a sequencer, and they were very nice of like showing me all the BAMs and cram files, and I'm like, okay, and like explaining everything so I can help them with their program. And I feel like as long as everyone's respectful and they realize I did not go to school for biology, and you did, and if that's okay, and there's things that I know you don't know, and like everyone said, as long as everyone plays nice, it's a very easy to collaborate with each other and also learn new things. There are times I just hop on their calls and just like a fly on a wall and just learn, and those were fun too.
Yeah, it sounds like it's in most of your cases, learning never stops even after you leave college, and like you continue to learn from your from your colleagues, um, and also like the situation that it brings. And Mariana, you earlier spoke about how like COVID had changed some of the well, you talked a little bit about the results of COVID, given that you had to process a lot of tests in a day. And yeah, I feel like most of our viewers here would like to learn about how COVID has impacted your teams and the way that you work. Maybe also in exposing some of the weaknesses in the healthcare system and how we can better approach some of the problems. Pocket, if you have anything to say.
Um, I might not be the best person because I think I joined the workforce when COVID was in effect because I graduated in 2020. So this is the only work paradigm I've known. In terms of like, I think the Broad has done, I think Mariani can speak a lot more to this, but I think the Broad has done a really fantastic job of like the genomics platform, adapting the infrastructure and the technology that we had and like really, really addressing this public health crisis. So like at one point we were like processing the most tests in this part of the world, and that's like really like impactful research going on. I don't work with COVID, so I would love to hear from other folks. I do think like there are interesting advantages of working remotely and like flexibly in these kinds of teams. And I've actually found I've been able to get a lot of face time with clinical researchers and doctors when sort of we can meet virtually and like our schedules are more flexible. And yeah, I think there are like upsides and downsides, but it has been really cool to the ways that I think we've all adapted and we're still able to do like really interesting research despite sort of the circumstances of the world.
Yeah. Oh no, I was just going to, because I did explain like now a lot of things are more virtual because of COVID, but I did wanted to switch because I saw a question. Interviewing now, because I just did an interview or was an interviewee. Someone came to us for an interview and I was on the panel, and the interview process now was kind of different because everything's virtual. The coding, if for anyone who wants like tips on internships, I would suggest like focusing on creating a project that you're proud of, even if it's in school or out school, and then like explaining that project, try to go very in detail in the code, and also practice coding on the spot, because now they can see, like before you could just write in a whiteboard and that was less stressful. Now some people will ask to code in front of them. So just practice coding in front of somebody, and that's a big change. I know if I was interviewing and I had to code in front of someone, I would probably freak out a little bit. So that's something to keep in mind in the virtual world. If anyone who's trying to apply for jobs and there's a coding portion, they might ask for you to code while sharing your screen.
So I just wanted to point out that during COVID, my lab it's all computational. So for us, we just all went to our homes and worked. However, in doing AI, you need training data, you need truth. So with the clinicians having more time on their hand, we actually, using ThinLink, set them up so that they actually participated more in the research. They could help identify lesions, outline necessary things, because they were sent home. But through their computer, we were able to integrate them even better than if they're on campus, they would get called away to do a case. So that was good. COVID is bad, but the fact that they were around was good. Also, through the NIBIB, we created MIDRC, MIDRC.org. It's a 20 million 2-year contract. I'm the contact PI on it. And that expedited a plan that we all had wanted to do, which was to create a medical imaging repository community. It was expedited when COVID hit. So in a way, my lab increased its productivity during COVID. However, the folks with the wet labs by me actually were hurt. They went down in productivity. So we'll see how it goes now.
Yeah, there's a big difference in how like teams have been able to adjust and how COVID has also impacted them as well. Since we're almost at time, we only have like 5 or so minutes left. It'll be really nice to hear from all of you about like final things you might want to say to our viewers who are mostly undergraduate students, just like we were once. I'm sure a lot of us would value learning about how to keep going in a space where women are not as represented, or people of color, minority groups are also not as highly represented. Yeah, any final remarks if you have?
Yeah, maybe I can start. I really do, like I said, encourage everyone to kind of try to leave your fears or imposter syndrome behind and just go for the things that you love. Benevolent AI is the company that I work for, and we are really committed to supporting emerging female talent and supporting diversity initiative projects and diversity and inclusion projects. So like anybody who's interested in that particular company or just interested in getting in touch with me and talking about it, I'm very happy to to give you any career advice or just chat and hear your thoughts. I think like I said, we all bring so much to the table. Interdisciplinary environments need not only different disciplines but different voices. So please do continue on your path and follow things you're interested in.
Yeah, I completely agree with that. I think there have been a lot of people that have looked out for me on this journey, because I think it's difficult to get into tech without any background, and it can be sort of, you might not realize what impact you're having on someone. Like, I took this linguistics class with a computer science professor, and she just really believed in me and thought that I could do it, even though she had no reason to. And that was enough for me to stick through an entire major, just like she believing in me. And I think we have a real opportunity to build community and do that for other people. So yeah, please reach out and keep going.
Yeah, I totally agree with that. And I think it's really important for us to not just mentor, but sponsor the next generation. Sponsoring is where someone, a couple people, opportunity falls in your lap, say, oh, you would be great for that. You connect them. It's up to them to take the ball and run with it. I know as I progressed through my training, through the various college, graduate school, I was given a lot of opportunities, summer jobs. So that's why I do. I think it's paid forward. And so I always take 4 to 6 high school or undergrads in the lab per summer. And you need to make that connection. And I think everyone should do that.
Yeah, that's really cool that you do that, Mary Ellen, because that is definitely what we need. Like, once you have the opportunity to start supporting other females to help grow the field. And I think for me, I know in college it was hard, and even in the field right now, but always being not afraid to speak up when it's too much. Sometimes someone of higher power is over talking you in meetings constantly or something like that. Feel like you don't have to go to the higher up, but maybe talk to people around, see guidance, go to HR. There's one time I had to go to HR because it was just too much, and see if that place is good for your mental health. You might have to leave if the place is not. And doing those steps also would help, because that you're smart, and we know that coding is hard, and we're able to do those things like physics, and we should all know that even if someone doesn't believe in us, we belong here and we are good enough. And that, yeah, I had something going, but it's good. It's good. Support one another.
Yeah, beautiful. Thank you, Marianne, for sharing that with us. And I'm sure your experience resonates with a lot of us. And I want to thank everyone for taking the time out of your day to tell us about the work that you do, your passion, and dedicating a lot of time to all of us to walk us through how healthcare is really important and how technology can be used in solving some of the problems that we see, especially in the US, where healthcare is not where it needs to be. And some of the takeaways that I definitely have from this panel is believe in yourself, go do what you feel like you're meant to do, and while you do it, support others along the way. It doesn't need to be a lonely trip. Yeah, thank you so much. I will try and take away as much as I can from this panel, and I'm sure most of our viewers will as well. But it's so sad that this is the only amount of time that we have. I wish we had longer, but still, thank you so much.
Thank you for being a great moderator.
Thank you.
Good job.
Yeah.
Okay,
Thanks,
have a
everyone.
good day. Bye.
Bye.